From the world of AV programming and control with James King, I'm Steve Greenblatt, and this is Ask the Programmer. James, how are you today? I'm excited about our conversation and looking forward to another great podcast.
I'm doing great, Steve. I'm looking forward to this episode. How are you doing?
Doing well. It's great. We're recording and springtime is here. It's and things are we're headed on the way to InfoComm. So lots of good things happening. We have a returning guest today. If you didn't catch the previous episode, episode 265, stop now and listen to that one because this one is going to be a great continuation and more in detail about what's happening at Dartmouth College. And our guest today, Mark Franklin, he's the Senior Director of Computing Services at Thayer School of Engineering at Dartmouth College. Welcome back, Mark.
Thank you. Glad to have the opportunity to describe a different way people can think about AV.
And it is so refreshing and interesting and thought-provoking, and we really had a great conversation in our last episode. And we're going to go a little bit deeper into some of the technology that you're using and some of the ways that you've been able to roll out updates and test and also do some maintenance. So tell us a little bit about the specifics of the technology you're using and what are some of the findings that you've had.
Sure. So we run our control processor is a Raspberry Pi computer, way less expensive than the AV counterparts, and as far as I can tell, way faster. We can control multiple rooms off one Raspberry Pi. Um, we run Dockers on the Raspberry Pi. We have multiple uses for the Dockers. One is a web server, which serves up the user interface. So um, also we have microservices, which is a term coined from BYU, pioneers in this area. They microservice is essentially a shim between we call it the orchestrator web server, which is running the GUI, and the devices in the room. We all know AV devices, they're not very consistent about protocols. There's foibles, bugs, various degrees of evolution away from this is an RS-232 connection with you're sending characters across. So we didn't want to have our web server that's running the GUI responsible for dealing with all that cacophony of protocols. So we have other web servers running in those Dockers for them to be microservices, which expose a REST API, which then will take nice REST commands from the control web server and translate into whatever the devices need to do their thing. Some of those devices are communicating over UDP and Telnet and sockets, and one of them has a REST API. So that's the way we orchestrate. This is as a programmer, right? We architected this thing so we could have a clean way to deal with that. Also, we were able to do things like let's make a PJ Link microservice, which uses an open standard. Remember, OpenAV. So we don't have to reprogram for every projector. Turns out they all implement PJ Link, at least the ones we've encountered, well enough that we can control all of them with this one microservice. So that was nice win. We put all the software in GitHub. The last episode I said it, but I'll say it again, github.com/Dartmouth-OpenAV. It's all out there. You can go check it out, use it. We hope you will. We're actively seeking collaborators. So GitHub has the source code in it. It has an explanation of what we did, but also we put configs, and that's not public. Our config files, we didn't want to expose those to the world because they're very Dartmouth specific, but that's just a JSON file format specifically tuned for describing rooms, what equipment's in the rooms, what buttons do we want to put to facing the user, and what do you do when the user presses those buttons. So user presses the button to turn on display one. Well, that will send the PJ Link command out to the projector. It'll contact the microservice to send that command. It'll contact another microservice, talk to a global cache device. which is a relay, network control relay, which will lower the screen. And then there are more buttons for changing the input. You press that button and it'll send through the microservice the correct command to a Kramer video switcher to switch the input that's going to that screen, I'm sorry, that display to the correct input. So that's sort of in a really quick summary how the controls work. We did a lot of work on the microservices for concurrency and caching to make the system performant. We have volume sliders in our system. And remember, so when you move the volume slider, you're in a web browser running on a Raspberry Pi, which has to then communicate with a microservice, which then has to communicate with the device. And of course, we follow the best practices. When you send a command to a device, you actually verify that it got the device and that it said there were no errors. So making a round trip every time they dragged the volume slider a little bit you could get way ahead of it in the early incarnations of this. So instead, we changed the microservice so it says, "Yep, I'm going to set that. I promise." And I will also, if you check for errors later, I'll tell you if I didn't succeed. So now it's queuing up those commands and also not waiting to check the status of the device when the GUI wants to know which inputs are my three displays on. The microservice has that information cached. So as soon as it gets queried once for that particular output, what input are you on? Then it knows. It just periodically goes and asks the hardware, what input are you on? So you could, again, best practice, verify what's in the hardware. So a user could walk up to our video switcher, change the input, and our system would catch up fairly quickly because it would actually be polling and tell, but we're not making the GUI wait while all this happens. The Raspberry Pis, the microservices are very fast. So we get snappy performance. You can drag that volume slider. We also tuned the web application so it wouldn't send out at a really fast rate. You can drag it, and the volume in the room tracks dragging the volume slider. So that worked out well. The config files are easy to update, although you got to know JSON. So there was a little culture clash when we brought the central Dartmouth people in. They didn't know the IT technologies. So they had to learn about JSON. They had to learn that, yeah, it really matters. You got to get all the commas and the semicolons in the right places. Saving grace on that is they're very repetitive. We try to keep things simple. So we have a fleet of rooms. If it's a classroom, there's a pretty standard set that goes into it. It might have a document camera in one and not in the other, but overall it's quite consistent. So programming a room ends up being copy the JSON config file, change the names of the devices, and you have a new room. But wanted to talk about a big advantage of this is we're empowered. We can fix anything. We can design the rooms. We can build the rooms. We actually have people on staff now installing the hardware. And when something goes wrong, we understand the entire stack. We can fix it. Of course, ultimately, the devices are black boxes, but we chose devices which prove reliable. We had a different video switcher vendor, which the network stack wasn't reliable, so we fired them and we got the Kramers. We have two different kinds of DSPs, Shure and Biamp. Unfortunately, during COVID times, the Shure P300 wasn't available. So they're using Biamp Tesseras in the central facility, the central rooms. And it's actually better DSP in many ways, but it's also more expensive. So we really enjoy being able to walk in a room knowing that whatever's wrong with it, we can fix it. And we have the developers here. We're seeking collaborators. I realize collaborating places using OpenAV wouldn't necessarily have the developers, but they would have access to the developers. And we can go as deep as we have to fix the problems. So we've been doing that for 6 years. So the system is quite robust. We fix the bugs. We don't live with them. We don't end up satisfied with just we're going to reboot the system and hope it comes back in 5 minutes. They do come back. They come back in 2 minutes, but we almost never have to reboot them. The Pis are incredibly reliable. They run for months. It's pretty much most of the Pis don't reboot except when we get to our 10-week cycle and we're going to update whatever software. We have a failover scheme which has worked out incredibly well for us. I'll talk architecture a little bit. We wanted to put the pies in the room because that way, if the room got isolated from the network, you could still use the AV system. Remember, we made this decision 7 years ago. We were designing, and it was a good decision. It worked. The pies are cheap. The pies are awesome. But as soon as we put Zoom Room in there, now we have a dependency on the external network anyway. Zoom is down if the room is down. I mean, if the network connection is down. So we ended up, we coach people, if that happens, switch to HDMI because we still have HDMI inputs. But we're much more dependent on the external network now than we anticipated. And we could actually, we built this stuff, we can do what we want. Collaborators could do what they want. You could instead of running the control software on Raspberry Pis, you could put it on a couple of VMs in your data center or even in the cloud if you want to be dependent on your internet connection too. But we like having the Pis in the room. In the last session I talked about, we're synthesizing audio. So we can warn people when we're going to start a recording. We have automated classroom recordings. We can tell them when we're going to do the automated testing I mentioned last episode. And also, don't listen, Zoom. We reverse engineered their ultrasonic protocol so we can put on the speakers in the room instead of just on the tablet. We can put out the auto join sequence of ultrasound. So we like having the Pis in the room. But another way we leverage those Pis is there's part of this web server paradigm is we put Android tablets, inexpensive Android tablets. The central folks they're more distributed. They don't want to rely on the $150 tablets we're buying, but the engineering school is literally buying $150 tablets straight out of China, probably what they put on manufacturing floors. Anyway, it's just a batteryless Android tablet. And it's running, we captured it with a browser software. So it only runs the one URL, which is its Raspberry Pi. So it knows what it gets the right controls in the room. That is JavaScript. It's actually taking config information that the orchestrator, the web server, the control web server passes to it and interpreting it and rendering the buttons. So that's literally on the fly. Every time the system comes up is how we render the GUI. That JavaScript also is aware of is its web server running on the Pi, is it responding? If it isn't, the JavaScript has a list of alternate Raspberry Pis it can go to. We call that failover. So if that Pi fails, they don't, so that was kind of unimportant, but if it did, the touch panel would literally go find another one within 15 seconds. Where that comes in really handy is if we want to do maintenance on those rooms, we don't have to schedule downtime. We could literally just reimage a Pi, do whatever we want to it, and the touch panel is just going to say, sure, I'll go find another one. It doesn't matter. Highly resilient, and it's worked out incredibly well in practice. So those are some of the benefits. I did mention there was a culture shift, and I've talked to a lot of institutions about OpenAV. It's not the way people in traditional AV roles are used to. We are fully responsible for everything. We can't blame the integrator. If it's not working, it's our fault. And there's technologies that the AV people have invested in, and simple programming is out. You could have somebody who knows simple programming on staff, and those tend to be the ones that seem the happiest with the existing paradigm, is the ones who have empowered themselves by getting a programmer. But in our world, these are standard IT technologies. Our CIO loved it because he's got these people with skills already. He was able to take people from elsewhere in his team and put them on the OpenAV project, and they're learning things doing OpenAV that would be useful if they repurpose them back into the other roles in that IT team, as opposed to you have a Crestron or a QSys programmer, and those skills don't go anywhere else in the team. But there was a culture shift. Some of them didn't like having to learn exactly how to get all the semicolons and commas correct in the config file. But a lot of them did convert, and I really like seeing, especially that people with less experience in this world come in And then now they're becoming expert, and they're becoming expert rather quickly because these are straightforward technologies. You can ask Claude or Gemini or whoever about how do I do this, and it's fun watching people come in and pretty soon they're programming rooms without having to go to whatever vendor school.
Really, really fascinating. I have a couple of questions, but I want to
Yeah.
bring James into the conversation and get your thoughts about are we seeing what the future holds right here?
Yes, we are definitely seeing what the future holds. And it's funny to think about this is I applaud Mark and his team. I know he said what you started about 6 years on this, correct, Mark? Funny enough is I was just when you said that I was tracking back in my mind. It was about that time when I was starting my own, running my own kind of system because I wasn't happy with what we were doing. But then I changed jobs and I kind of abandoned that project. So it's just, you know, great way to keep it going. And I love hearing everything you're doing.
One of the thoughts that I had is, how do you evaluate a new product? How do you go about exploring changes and updates and so forth?
You're talking about devices?
Yes.
Yeah, so first criteria, we won't even look at it if you can't control it over an Ethernet. Like I said, we had a vendor, video switcher vendor. The first one we picked looked great on paper, but as we were trying to program it, the network stack just kept flaking out in sporadic, unpredictable ways. I contacted the vendor and they started saying things like, well, after you do this operation, you have to wait a certain amount of time. I'm like, oh, wait, no, that's not how reliable IT communications work.
Yeah.
Then start looking at what is the control protocol? Is it well documented? Um, Another vendor, the video switcher, they're not that consistent about their protocol. We didn't know that. The one we picked to do first was actually the best one. And so we were pretty well committed to that product line when we started realizing that they weren't consistent. Mute one was muted in one product and mute zero was muted in another product. So we had to code around that. Fortunately, they had the foresight to provide a call, what kind of product are you? So now we call, the microservice calls and says, what are you? Okay, now I know how to make you mute. Um, so cost matters. Engineering school, we like to say we're scrappy, we're cheap. We're building full hybrid Zoom room classrooms. It's about $22,000 worth of hardware. And then, of course, we program it. So there's a hidden cost there. But um, so we didn't get that way by picking the most expensive stuff. The cameras we're using are Prisuals from Amazon. They're $650 pan-tilt zoom cameras. There's another difference of opinion. The central folks don't want to take the risk on the low-end cameras. So they're buying much more expensive cameras. But we've had really good luck. We've had one of those Prisuals in 6 years fail. We have two cameras. We have well over 100 cameras that have been in service for, on average, 5 years. And we had one fail. Um, so we're cheap. I acknowledge we're cheap. We chose Hope Star Android tablets, $150 tablet. We undershot a little bit on that one. It turns out the first one model we bought was probably had bad flash. The way we were running it, they eventually wore out. So the way we reacted to that was, okay, if you power cycle them, it comes back and it might run for another 2 weeks before it has a problem again. So we used our monitoring, the Nagios monitoring. We made it slightly proactive. We were actually monitoring content on the screen. If we notice the content on the screen is wrong, we power cycle it because it's plugged into a a network switch. We can do PoE power cycling. So we eked out a lot more life out of that. And we found another model then which didn't have this problem. So now we're on the second model, replacing the first ones. And even for the rooms where we had to replace, which is not all of them, we spent $300 on touch panels, whereas the industry standard ones are more like $800. So I don't know, you might not necessarily want to do what we do. We're others, I respect the central folks at Dartmouth want to do. They're buying more reliable equipment. They're more distributed. They can't run all over the place. But I have to say, those discrete components have been incredibly reliable. The stuff just works.
It sounds like your choices, you have been proven to be successful. What is how, when you go about implementing something new or a change, are you getting feedback from your users and are you doing iteration and mock-ups and stuff to roll up before you roll out an update?
So I describe my team. We're sort of like benign dictators with AV. We got into a long time ago when we started fixing those awful systems. We got credibility with the community. And they sort of just delegated, you guys do what you want with AV, and we'll let you know if it's not working. But the requests we get are like, could you put a second camera in here? Or can I have another preset? We seem to have, on our own, anticipated what they would need and implemented that. The Central Dartmouth folks are much more on the model you're describing. They talk to faculty and other users before they build a room. They get feedback and then they check with them after the fact. The other thing is my team is a fairly small facility here where our offices are literally interspersed with our customers. And we're running over there sometimes while the thing's going on and fixing the problem. So we're rather well tuned into what our users' needs are as opposed to a more centralized team on a larger plant where they don't actually know the faculty that are using the systems.
So I think you've shared so much great stuff. Before we wrap up, um, what would you advise to somebody that's looking to go down this road? And I know that you have two, great wiki, I've really enjoyed reading through it, and gave them you provide a good launching point for people that want to see a proof of concept.
If somebody's sincerely interested in implementing this, I would love to talk with them about it. We have full disclosure, we have one other institution that's implementing OpenAV and contributing code. We would love to have more. We've had others that started. It's an interesting blend of AV and IT that you need to do this. My team, by definition, we were doing both, so we had it. And then of course we were able to inject the IT into the AV team and the central Dartmouth folks. But you want to, if you're thinking about implementing an institutional scale thing like ours, you want to make sure you have excellent relationships with your network services team. And you need to figure out where you're going to get the AV and the IT skills blended. And then we call it quick start script. We're working on ways to make this easy for others. And I think we've succeeded to some degree. It's still pretty complicated. But this is definitely feasible if you're willing to invest the right resources into it.
Well, I must say you make it sound very appealing, and you make it sound like you've been able to put this in with almost with ease. So kudos to you. And
It was a team effort, a very inspired team.
yes,
At times it wasn't easy, but it's gone incredibly well.
that's so amazing. Well, we or definitely feel like we're going to have you back on a future episode. Until then, how can people get in touch with you? How can they learn more about OpenAV um, how can they continue this conversation? Hopefully, reaching out to you.
My email address is mark.j.franklin@dartmouth.edu.
Wonderful. And that URL again for
Sure,
OpenAV.
it's github.com/Dartmouth-OpenAV.
Excellent. Well, thank you so much. You've really provided us with some really eye-opening insight, and it's really fascinating what you're doing. And I think you and your team should be very proud of the results that you're getting.
Thank you for the opportunity.
You're welcome. And James, what are your final thoughts on this? We've been able to get a lot of really insightful information from Mark over the past two episodes.
It's been great information. I know I'll be amiss if I don't prep this. I want to definitely say I think we need to have Mark back at least for another one or two or 10 episodes because there's so much information here. One, I'll tease because hopefully we can get Mark back that we can dive into it. I need to know the security of this software, how well the security is, especially like, when we get into HIPAA and FERPA and all that stuff to be considered as well. But we don't have the time to dive into that now. Again, great information, Mark. Good work what you and your team are doing. If anyone wants to get a hold of me, I'm in the Ask the Program community. And also Google me, you'll find me.
And I'll also say that Mark just mentioned it briefly, but I know he has a lot to say about using AI for programming. So we'll be talking about that in the future as well. So much great stuff. For me, you can reach me at Steve Greenblatt on social platforms. LinkedIn is the best place. As James said, the LinkedIn community, the LinkedIn group is where we try to bring the Ask the Programmer community together. We'll hope that Mark will join us there, and we'll also be able to provide more information and continue some of these conversations. This podcast, if you are watching it on YouTube, is also available on the go on your favorite podcast player. And if you're listening, you can watch us on YouTube. Both are great places to leave a rating, review, comment, share your favorite episode. We'd really like to hear from you. And we really want to continue this string of amazing guests that we've been having. And so if you'd like to be part of the program, please reach out to us and let us know you're out there. All it takes is raise your hand, and we'd like to have you part of the show. And we'd like to bring so much more great content and insight to our audience. We thank you for listening. Thank you for watching. Until next time, this has been Ask the Programmer.